Herb Grover here. As Vice President of Waimanusha Audubon Society here in Pagosa Springs, Colorado, I've had the privilege over the past 3 years of working with our chapter president, Gene Zernhelt, and with Keith Bruno, Southwest Colorado Community Naturalist with Audubon Rockies, to coordinate a citizen science project examining the response of bird communities in ponderosa pine forests to wildland fuel reduction treatments. That is prescribed fire and mastication or mowing of the forest understory. This project was also conducted in cooperation with the Mountain Studies Institute, located in Durango, Colorado, and the San Juan Headwaters Forest Health Partnership, a consortium of federal and state agencies, several private land trusts, and other citizen organizations, including the Waimanusha Audubon Society. The overall design and site characteristics for our study are summarized very nicely in a separate 10-minute video that you may view by following the link in the comment section below. And then links to our third-year project report and to previous years' reports and videos are also posted in the comment section below. In this video, we want to continue telling our story of how birds can help us understand the health of a forest ecosystem. Sometimes we need data to tell that story, but perhaps the more compelling content comes from the experience of the volunteers who helped conduct the studies.
I really enjoyed working on this bird monitoring project, mostly at Jackson Mountain. And what I really come away from it with, the biggest benefit to me is all the fine details, the intimate details that you see in the woods that you can't possibly appreciate from a car or even a fast walk.
Now, a little background. A few years ago, some of our members were curious about the response of the bird community in our area to prescribed fire and other wildland fuel reduction treatments. Noting that there are several of our chapter members who are dedicated and skilled birders, we saw an opportunity to bird with a purpose. This prompted us to pursue the scientific question at the heart of our study. That is, how might the bird community in a ponderosa pine forest respond to prescribed fire or understory mastication? But we view the other volunteer-based objectives of this study as equally important. And these are to improve the volunteers' understanding of forest and fire ecology, to improve their birding skills, give them experience participating in field research, and also strengthen the already healthy commitment to conservation issues that our chapter members share. We believe that our project has been phenomenally successful in meeting all of these objectives. In fact, over the past 3 years, more than 40 volunteers have invested well over 600 hours each year in the conduct of this study. In each year of the study, more than 20 of these dedicated birders have contributed to the project, with 12 of our volunteers participating in all 3 years. Our volunteer brigade is multi-generational, ranging in age from the teens to several members in their 70s, and a couple of octogenarians as well. Their backgrounds include active and retired merchants, mechanics, contractors, educators, various other professionals, as well as several students and even a few academics like myself.
I think my favorite thing about this project is it reminds me why I got into this field. When I was 22, 23, I moved to the Gila National Forest to do point counts on a post-prescribed fire cavity nesting survey. And that's essentially, at least at this site, almost what we're doing. And more than anything, it's just bettering my skills, reminding myself that, you know, the avian world is totally magical, and coming out here and sharing that with other people. We have discoveries every time we go out. There's something new. We find nests, we find different species, we learn more about behavior. And for me, that reminds me of why I got into birding in the first place.
Hi, this is Holly. This is my first year of getting involved with the bird monitoring surveys, and really enjoyed the experience. I think it's great that this kind of data is being collected for the different types of sites and the different habitats, and it'll be something that can be looked back over the years to be able to evaluate different kinds of things that are happening. So really enjoyed the experience.
Well, now, since our previous 2021 video and earlier videos show the 3 sites selected for our study pretty well, I'm going to quickly summarize their characteristics and not dwell on them. In doing so, note that all 3 sites are located within about 10 miles of Pagosa Springs and are dominated by ponderosa pine. Due to wildland fuel reduction treatments, or the lack thereof, the sites differ in the density and height of the tree canopy and the understory shrub layer, which is made up primarily of Gambel's oak. The Turkey Springs site was subject to prescribed fire at the outset of our study in 2019, and consequently has the shortest and least developed shrub layer. The Fawn Gulch site, which had been masticated or mowed in 2017, has a shrub layer that is further along in recovery from treatment, and there are scattered mature clusters of Gambel's oak throughout the site, some of those clusters reaching 10 or 15 feet in height. Finally, the Jackson Mountain site that I've alluded to was chosen for comparison because it had not been subject to wildland fuel reduction treatments or logging for many decades. The shrub layer there is notably more diverse, dense, and taller than encountered at either of the other 2 sites, and that's going to prove to be important in some of the findings that we're going to come to soon.
I look forward to this experience every year. I've completed my 2nd year doing this particular activity, and it's important for a lot of different reasons. One of those reasons is that I really feel like the more information that we can gather on any particular location helps us manage it better over the long run. And so the bird monitoring project is an opportunity for us to collect an enormous amount of data that then we can use in trying to develop management plans for places like Jackson Mountain, and certainly the same thing throughout the National Forest.
Well, just to review quickly our field methodology, here are some important points. First of all, the sample season corresponded with the initial breeding season for birds in our area, which we consider to be late May to early July. There were 15 sample points located at least 75 meters apart at each of these 3 sites. These were arranged in loops of 5 points each to simplify visitation scheduling and hiking time. Now, the sampling consisted of recording birds that could be definitively identified by sight or by song during a 6-minute period at each of these monitoring points. Now, sampling took place between 7 and 10 a.m. on fair weather days, and this is quite consistent with the methodology that we saw in the literature. Now, finally, to avoid double visits on any single day, we had a coordinator for each site to help schedule the teams. Well, let's begin by looking at how many bird species were found at each site across the 3 years of the study. The y-axis on this graph is the number of bird species, and the years are shown across the horizontal axis, and the sites are color-coded. The blue is Turkey Springs, orange is Fawn Gulch, and gray is Jackson Mountain. As showed in the highlighted area, Fawn Gulch had the greatest number of species when looking across all 3 years of the study. 63 of the 82 different species were observed at Fawn Gulch. Well, there were 49 species observed at Turkey Springs, and 58 of the 82 total species were observed at Jackson Mountain. Well, Jackson Mountain, however, consistently had the greatest number of species recorded in any given year. Note that the number of bird species observed in each year of the study increased at Turkey Springs, indicating to us a recovery of the bird community from the initial impacts of prescribed fire, which the prescribed fire simplified the structure of the forest by essentially suppressing the shrub layer for at least the first year following treatment.
The most important thing I think that I have learned is the forest ecology, what impact the local fire burn areas have had on the birds and the plant life. I've also really been brought home with the importance of protecting our areas and our local forest.
Now, biodiversity is one of those slippery concepts in ecology. Most people, when they hear the term, well, they think about the number of species present. But there's more to that concept than just number of species. Now, here's a slide from Ecology 101 with a community of M&Ms as a model. Community A and Community B have the same number of species, indicated by colors of M&Ms, and also the same number of individuals, but they differ in how the individuals are divided among species. In Community A, the yellow species has 6 individuals, with each of the other species having 1 individual each. In Community B, each species has 2 individuals. Well, the number of species is called species richness, and how individual organisms are distributed among species is called species evenness. Well, take a look at this. Which of these communities do you think is most diverse? Which community is likely to have the greatest resilience to changes in the environment? Well, intuitively, the community with the greater species evenness, that's Community B, would likely be more resilient to environmental change. And so when we think about how biodiversity benefits an ecological community, we have to consider both species richness and species evenness. Well, maybe you can draw an analogy to supply chains. That's big in the media right now. And how supply chains can be disrupted if there are too few suppliers, or if some suppliers can produce a lot of something with others producing only a little. In ecology, we use indices calculated from species richness and species evenness data to indicate species diversity. The index I show here is called the effective number of species. Now remember, this is an index. The effective number of species does not refer to actual species. There's a lot more on this, how this index is derived and so forth in our report. Now, Jackson Mountain is shown to have the highest effective number of species, reflecting the finding that that site had the greatest number of species in 2 of the 3 years of our study. And Jackson Mountain, based on the calculations of another index that I'm not showing here, also had the greatest species evenness. This finding is not surprising. It corresponds to another basic principle in ecology, the correlation between number of bird species and what's called foliage height diversity. Well, remember how well developed the shrub layer is at Jackson Mountain versus the other 2 sites? Well, think of it this way. Foliage is the banquet table that birds are feeding on. If you have more tables, you have more options for more birds and for more different bird species. There are more niches available.
Probably what I think is most valuable for me personally is returning to the same spots on a regular basis throughout the breeding season to see the changes in the vegetation, in the bird community, species composition, and bird behavior. So it's been a terrific way to get to know the avifauna here. Hopefully we're making some contributions to a better understanding of the ecology, and I'm certainly looking forward to many more seasons of this study.
Now, not surprisingly, bird species divide up the environment based on what they eat and where they find their food. We can use the term feeding guilds to refer to these habits. The definitions of several feeding guilds are shown on this slide. Well, there's ground brush foraging species. The American robin is one of those. Or timber foliage searching species. Some warblers behave this way, and chickadees do as well. Then there are the aerial flycatchers. These are birds that capture their food on the fly, on the wing, so to speak. Swallows and nighthawks are considered aerial flycatchers. And then there are just flycatchers. Well, some warblers and western wood peewees, for example, will perch on a branch or on some foliage and then fly out and catch insects as those insects fly by. Then we have timber drilling and gleaning species. Well, we can relate to these as woodpeckers and nuthatches. They search for insects on the bark of a tree. Now, on the graph that I show here, the y-axis shows the relative abundance of species categorized into their respective feeding guilds for each site, and they're color-coded by year. The horizontal axis shows the respective feeding guilds, at least the ones we've selected to show here. Not all of them are shown. Now, in this version of the graph, I've added a horizontal arrow to help serve as a reference point. It's set at the 40% relative abundance level on each graph. Now, there are several takeaways from this graph, but I'm only going to mention a couple of them. First, ground brush foraging species are most common at each site in all 3 years. Secondly, flycatchers are very important at Fawn Gulch and Turkey Springs, but not very important at Jackson Mountain. Well, this is due to a high incidence of western wood peewees favoring the open canopy at Fawn Gulch and violet-green swallows at Turkey Springs. Now, the violet-green swallows at Turkey Springs benefited from several dead snags, and we're going to talk about that coming up. But they also benefited from the open canopy. So when looking across the array of species at each site, they're similar in having ground brush foraging species as the most abundant feeding guild. But there are differences in the predominance of species fitting into the other feeding guilds, reflecting the quality of habitat for birds based on their feeding strategies. Now, many of these differences can be attributed to the condition of the shrub and understory layers at each site, which, again, we keep saying this, are affected by fuel reduction treatments. But as noted for the violet-green swallows at Turkey Springs, the availability of nest sites may play an important role as well.
One of the highlights for me has been to observe all of the nesting birds. Up on Jackson Mountain, we have found snag trees to be super important for nest sites. We have seen over the past years house wrens, pygmy nuthatches, flickers, Williamson sapsuckers, and violet-green swallows all nesting on the same snag, not at the same time. A favorite of mine has been the warbling vireo. This is the 3rd year we have observed warbling vireos building nests. They're pretty easy to find if you follow their song, because they sing all the time, even when they're sitting on the nest.
Which brings us to the next major topic, and that is, where do birds prefer to build their nests? Well, some build their nests as cups of various kinds of nesting materials in the branches of trees and shrubs. Now, 43 of the 82 species we observed prefer to build their nests in this way. Some build their nests on the ground or on ledges or even burrow into cliffs. And 19 of the species we counted behave in this way. But of greater interest to us is the 20 species that build their nests in cavities, excavated in living or dead trees. Now, cavity nesters represented about 45% of the birds counted at Turkey Springs, largely because of the abundance of violet-green swallows, about 21% of the birds at Fawn Gulch, and almost 30% of the birds at Jackson Mountain. Now, 5 of the 12 most common bird species across all 3 years are cavity nesters, accounting for about 28% of all birds counted. Among the most common cavity nesters were pygmy and white-breasted nuthatches, northern flickers, and hairy woodpeckers. Cavity nesters can be divided into those species that excavate new cavities in dead snags or in decaying portions of living trees. And these are called primary cavity nesters. And we show some examples here, includes northern flicker, for example. Secondary cavity nesters take advantage of abandoned cavities that maybe they've used in previous years or other species have used. And then some species are opportunistic. They may excavate their own nest cavities in some years or use existing cavities if available. Examples of secondary cavity nesters are the western bluebird and house wren. Example of those opportunistic species that may be primary or secondary nesters are nuthatches, chickadees, and even the Lewis's woodpecker. This sets up an interesting series of interactions between primary and secondary cavity nesting species. Well, you've heard the term food webs, that's who eats whom. Well, how about who excavates a nest cavity for whom? Well, that gives us a concept that we call nest webs. So some primary cavity nesters might be more important than others. Well, the northern flicker, for example, may be considered a keystone species because they are so important as primary excavators. Well, what does this keystone concept mean? Think in terms of the old stone arches that we see in old architecture. We look at how those stones are arranged and we see the shape of the stone at the apex of that arch is shaped in such a way that the other stones are pressing against it. If we remove that keystone, the arch collapses. Same thing goes with keystone species in ecological communities. What we found is that in some cases, if those keystone species are removed, there are drastic and dramatic changes in that ecological community as a consequence. Now, the Forest Service is very much aware of the importance of dead snags for cavity nesting species. In fact, they have what's called a wildlife tree program.
Trees like this snag provide important nesting habitat for many birds that are cavity nesters. And recognizing this, the Forest Service has designated these trees as wildlife trees, which, according to their sign, are saved for their food and shelter. Do not cut. This is to let people know who are out in the forest gathering firewood that these trees are left behind for wildlife.
Great. And we typically look for a tree has to be over 15 inches in diameter, and it needs to be within 300 feet of a road, an established road. And we're aiming to put it right up here at kind of line of sight height on the tree, so it's real visible for the public. There it is.
Well, that leads to another topic. And to enter into that topic, I'd like to recite an old adage that goes back many centuries in various forms. It goes like this. But for a nail, a shoe was lost. And but for a shoe, a horse was lost. But for a horse, a rider was lost. And but for a rider, a battle was lost. And so, for want of a nail, a kingdom was lost. The message of this adage applies to our study, in that we never know enough to ignore the potential unintended consequences of our management actions. So monitoring the conditions of forests subject to management practices of any kind is important. Now, all species deserve our attention and efforts to promote and protect their survival, regardless of their abundance or perceived role in forest ecosystems.
And I think the highlight of my whole thing was finding the nighthawk eggs when we found one of the birds that flew from the nest.
I did enjoy seeing the nighthawk babies when we first saw them. right after they'd hatched. We'd watch the eggs for 2 weeks, and that was just a real thrill. They looked like a little piece of fur that had fallen out of a tree. Just that's all they were, so tiny.
We looked, the eggs were broken, we couldn't find them. And then there were these little fuzzy things down there, and they had beaks and eyes. It was really awesome.
Well, this leads us to another topic, which is birds of concern. Now, we documented the presence of several bird species that are of concern to conservation biologists because of low population numbers or population declines. In addition to the common nighthawk that we just talked about, these include the Lewis's woodpecker, and there may only be 69,000 or so of those birds left worldwide. But then also there's Virginia's warbler, Cason's finch, pine siskin, band-tailed pigeons, and Grace's warblers, all of which we observed in our study. We have to remember that all species have intrinsic value, and we should do all that we can to avoid interfering with their survival and promote their survival at the same time. Well, our story is still unfolding, but we can say that wildland fuel reduction treatments that we've observed in our area are easily justified for the protection they afford residential communities from catastrophic wildfires. And let's remember, they also provide protection to forest ecosystems as well by minimizing the potential for catastrophic wildfires. Now, although there are short-term effects of prescribed fire or shrub mastication on bird communities, our study indicates that these impacts are short-lived, well, maybe just a couple of years, and tend to be pretty localized. Now, our study points to an inordinate significance of cavity nesting species, and therefore the need to be particularly careful to protect dead snags from prescribed fires, firewood cutters, and logging practices. Finally, by comparing the composition and structure of bird communities across our 3 study areas, we can infer that landscape heterogeneity, that is patchiness, which is promoted by wildland fuel reduction treatments, has a net positive impact on the ecology of a landscape. Patchiness at a moderate scale provides diverse habitats for a wider range of species, all of which contribute to improved ecosystem function and resilience in the face of a changing environment. Well, I don't think we know necessarily what the right scale is in all cases, but we can certainly surmise that disturbance at the scale of the catastrophic wildfires that span hundreds of thousands of acres, like those we see far too often in the West today, results in changes to forest ecosystems that are detrimental and may be irreversible. So our story is still unfolding and will come into clearer focus with additional years of study and data. We appreciate you watching this video and for showing an interest in our research and the story we are trying to tell. Remember the significance of a single nail or a single bird. Thanks again for watching.